Hey everyone, today in this video I'm going to try and go over how to add and subtract fractions. So before we can begin actually doing it with more complicated versions, I think it's important to understand the concepts behind how exactly we do add fractions. The first method we're going to discuss is thinking about it like language, because the best way in order to understand the foreign language of math is by translating it to English. When I'm given a problem such as the one on the displayed over here, 1/3 plus 1/3, we can easily convert it into English to try and understand it better. In that case, I'd assemble it more as 1/3 plus 1/3, where the third is acting more of a unit than anything else. This works in the same way as if I was adding one apple plus another apple, the apple becomes more of a unit. In that same way, we can just translate the unit down, and the answer is 2/3. That's how you understand it in a more conceptual way. Another more visual method is by using diagrams. If I was once again given 1/3 plus 1/3, I can try and divide up two different blocks into three parts. If I do that, I can begin by shading in 1/3 of the first diagram and 1/3 of the second diagram. Now, as you can see, we can easily translate this over, because if I know that one section is taken up here, I can just add that in. And now, out of the three possible pieces in this diagram, I'm using up 2/3 of it. It's important to note that there's only one reason we can do this so simply, and that's because these lines end in the same place. And by that I mean we can easily translate one part of the block over to another. If, for example, I had blocked this in a different way, where maybe one section was like this, and another section is like this, I can't take this piece and add it in here as clearly as I could if my diagram had lines that ended in the same place. But that doesn't mean that we can't do it. So the next part about this is learning how to find a common denominator. So in this example, I'm trying to add 1/3 to 1/4. If I just start off with the basic method that we went over, I will cut my diagram into three parts for the 1/3 and shade it in. Then I'd look at my 1/4 and I'd cut this into four pieces. Once it's cut into four pieces, I'd shade in 1/4 of that. But when I go in to follow that third final step and translate the piece over, I realize I can't because the lines are not adding up in the right way. So what exactly do we do then? That's when we have to find the multiples. So what this means is, I'm trying to find a number where I can make boundaries that line up with both 4s and 3s. That way I can translate one of them over to the other. In order to do this, I need to find a number that satisfies both of the different parts. And this is called the LCM, or least common multiple. I'm going to start off with 3. When I have 3, I can just start listing out, okay, I know it's 3, 6, 9, 12, 15, and so on. And when I look at 4, which is the other part I'm trying to figure out, I know it's 4, 8, 12, 16, and so on. And I didn't go on because I did notice something, which is 12 was the first number to appear 2 times. This means that if I cut my squares up into 12 pieces, maybe I can line up the boundaries. And that's what we're going to find out now. If I were to convert my 3 pieces into 12 pieces, I know that I'd have to split each one into 4 if I want it to be even. So I'm going to start doing that. As you can see, this evenly lines up, so this boundary right here is not disturbed, and I can exactly know that this is equal to 4 out of 12 parts. If I had converted it into something like 13 parts, there's no way I would be able to be absolutely certain where exactly it's ending. I'm going to convert the other one to 12 parts too. In this case, I'm going to divide it into 3s, because that's how I'm going to get my 12. Once again, this is 12 pieces. And I can clearly tell here that 3 out of 12 of the pieces are being taken up. Now that I know it's 4/12 and 3/12, the rest of it is quite simple. I can set up my equation, and just like in the example I just showed you, all we have to do is keep the denominator the same and do 4 plus 3, or 7. And that's how you know what 1/3 plus 1/4 is. And I understand you can't use diagrams every single time, but we can easily do it without too. If I'm given 1/3 plus 1/4, I just need to figure out how am I supposed to make the denominators the same. I'll look at my 1/3 first. I know that if I want the bottom to be 12, which we figure out by finding the LCM, I need to multiply the bottom by 4. But one key part of math you can never forget is you can't do something to one side of a fraction without doing it to the other. So I'm going to multiply the top by 4 too. 4 times 1 is 4, and 4 times 3 is 12. So I know that my first fraction can be changed to the equivalent version, 4/12, because we know it's the same exact amount as seen here. When I try to convert 1/3, and I'm going to try to convert 1/4 now. In this case, I don't need to multiply by 4 because that would get me 16. Instead, I want to multiply by 3 to get 12. And I'm going to do the exact same thing to the top. 3 times 1 is 3, and 4 times 3 is 12. If I add 3/12 to 4/12, I know the denominator can't be changed when adding. Only the top can. But because the denominator is the same, I know I can easily add these two, and I am left with the same exact answer, 7/12. For subtraction, it works in a very similar way, except the only difference is the final step would be, instead of doing, suppose I had the same thing, I would do 4/12 minus 3/12 at the end there, and be left with 1/12. That's how you add and subtract fractions that have different denominators. The final part of this video is figuring out how am I supposed to add and subtract decimals. When you have us adding and subtracting decimals, there's only one key point that you absolutely have to remember, which is you have to align the decimals. Aligning the decimals is what allows us to accurately do this. For example, if I'm given, as a basic one, 0.68 plus 0.73, what I like to do is, first off, know for certain that I'm not going to forget the decimals. And to do this, I'm just going to set up my decimals right away. I have my decimal here, and on top of that, I'm just going to put the decimal in the answer there as well, so I don't forget. Then I can go in and add the rest of the problem. 0.68, 0.73. From there, I'm just going to treat it like a normal problem. 8 plus 3 is 11. Add that above, and I'm left with 14. So I put in the 4, but where I want to put the 1, there's a decimal. So I'm just going to put it in the space next to it, because I know that the decimal can't be moved. And that's why the answer is 1.41. On the other hand, with subtraction, when I have my equation, I would want to set it up like this, so that this end aligns. But we know that that's not correct because the decimals are not aligned. Instead, what I need to do is set up my decimal beforehand. I'm going to put it in here, and like we discussed, I'm going to put it in the answer. Now I'm going to go ahead and fill everything else. I know it was 1.45, and the other one was 0.008. But there's a blank space here because we didn't do what we wanted to do, which is line up the edges, because that's not what you're supposed to do. Instead, just fill in a 0. Once I've filled in a 0, I can treat this like a normal math problem. I will just take this and make it 2, 4, 4, 1. My answer is 1.442. As you can see, the only reason this was possible is because I lined up the decimals. Otherwise, things get more complicated. You try to line it up like you usually do, but it's not going to get you the correct answer, and you don't know what to do with the decimals. As long as you keep your decimals in a straight line, you're going to be successful. Thank you so much for watching, and feel free to contact us if there's anything else you'd like to clarify.